Hi, everyone. We wanted to share our summer convergent project. So the name of this project is PEELS because we all love our acronyms, right? So this is packaging, evolving, and encasing little snacks. And this is a project about biopolymers in food packaging. And it's a convergent research and design project. So we wanted to take a minute to introduce ourselves.
My name is Claire. I'm an environmental sustainability, health and safety student at RIT. And if you don't know what that major is, it works a little bit with environmental sustainability and a little bit with occupational health and safety. So sometimes I'm working with hydrology and doing well testing. Sometimes I'm doing geology. Sometimes I'm doing social aspects and learning about sustainability. And sometimes I'm working with OSHA and certifications like that.
And my name is Ariella Knight, and I'm an industrial design MFA candidate entering my second year right now. I have a theater background, so I worked in theater for 16 years in New York City before going back to school. My work focuses right now on access and sustainability, and I threw my website in there. And for those of you who don't know what industrial design is, it is it's sort of the creative act of determining and defining a product's form and features. So that all takes place in advance of the manufacturing process. So that's sort of where we're coming from. So when we were both kind of onboarding into the Recipes Network, we watched the group meetings and kind of learned about some of the language that the network was using. And I think I said this last student meeting, like valorization, while the concept was familiar to me, the word wasn't. And same with convergence. I think I sort of understood what that meant probably, but it's not something I used in day-to-day language. And it became like a good sort of North Star for Clara and I in this project. So right here is just sort of how the NSF defines convergence, and specifically we were looking at a deep integration across disciplines. So when we started to talk about this and how maybe potentially we were well suited to do a convergent project because of our different backgrounds, we thought that it would be kind of good to put that in a graphic as a way to kind of help focus us. So we came up with this graphic, and the reason why there are these sort of Pac-Man-y features or characters is because we both had aspects to our different disciplines or sort of like pain points that we felt like maybe we're lacking a little bit. I felt like design lacked like robust research. Sometimes I was frustrated about that process. And Claire, do you want to say what you were?
Yeah. In my discipline, I feel like it lacks an approachability to the public. A lot of times we're using very hard to understand scientific models or representing data in a way that it's bulky and full of jargon and often hard to understand. So I feel like design kind of covers that.
Yeah, so we thought about like, so if these two Pac-Man kind of creatures converged, if they got into each other's space, then theoretically those areas that were less robust would have more support by the other discipline. And then there would be this little cross section in the middle, this sort of like lightning bolt where we could dip into each other's expertise and learn from each other also. And so early on in the project, I was in the student meeting where Swale, you brought up the double diamond. And this was really great timing because it was right about the time that Claire and I were going to talk about design process, and I was going to introduce her into what that might look like. And I was like, okay, great. So here there's already this graphic that the network's using. Let's just run with this. But we felt like for our purposes, it would be good to adapt that a little bit. And so we did. And And as you can see, we interjected these 3 kind of points at the moment of the most broad moment, where Claire's research and processes could really help us to narrow in a way that was wasn't performative, that felt like it had good data backing it. So you can see here, between the research and the synthesize, we added a life cycle assessment point. During the ideate and prototype phase, we added a best management practice. And at the very end, during the test and implement, before we could feel like comfortable that it entered into the solution sort of area, there's a circular economy analysis. So between the sort of Pac-Man graphic that we used, this kind of our take on the double diamond, and then also, of course, the recipes graphic, where we recognized at the bottom that sort of the incineration or landfilling is kind of the least desirable outcome for food waste. These, like I said a little bit earlier, these sort of became our North Star, something that we could touch back to over the course of the summer.
The other thing that was really helpful about this graphic is that we realized that food waste is a wicked problem. So there's many different layers to food waste, and it's a really dynamic and complex problem. So we wanted to kind of use it as a guiding way to decide where to start with our problem and to pinpoint what we wanted our solution to address. So our convergence solution led us to PEELS, which was the acronym we mentioned earlier: packages, evolving, and encasing little snacks. And so what we did was we've decided to create a biopolymer wrapping for single-size food items. And to do this, we worked on this project all summer, and we used design process while also using environmental science and the components that we mentioned in our double diamond pyramid as well. So one of the first problems we wanted to address was to reduce food waste through single-size food servings. So we read a lot of different papers, a lot of different studies that specifically were addressing how to reduce food waste in places like schools. Since the pandemic, there's been so many different changes to how we serve food and how we distribute food. So a common related policy is that you serve food in serving sizes, which does reduce food waste, is what we found. But when that happens, that also leads to an increase in single-use plastics. And coming from an environmental perspective, that is something we never wanted to do. So we had to kind of brainstorm and think, how can we reduce food waste while also not creating any further environmental implications? And so we thought, what if the food packaging was made from valorized food waste?
Yeah, and like we talked about earlier, you know, valorization is the process of converting waste into a usable commodity. We knew that there was a valorization cluster within the network, and so our sort of supervising professor, Dr. Whitney, reached out to the cluster and just kind of to make sure that there wasn't any overlapping or cross purposes that were happening. And it seemed like they were focused a lot on energy valorization that was happening. So we felt good about moving forward with what we were talking about with regard to food waste. And we looked into, well, since this is sort of a discussion of process, we go back just for 1 second, Claire.
Yeah.
Since this is sort of, you know, showing our process, we just had a big Google Doc brain dump, basically, where we're like, okay, where are there different, where are there points of waste in different, you know, food industries? And PEELS was something that just kind of kept coming up, and we both felt excited about it. And from my perspective as a designer, when you feel excited about something, then that is sort of reason enough to pursue it, because sometimes decision making can be really hard. And so the fact that we were both excited and sort of got a yes to PEELS is one of the reasons why we started to pursue that. And then you can go on.
Okay, I want to mention something really quick.
Yeah.
Another reason why we chose PEELS is that we recognize that right now in this world, there's a lot of food insecurity. And so we didn't want to take any food out of distribution to people who could be eating it, but we still wanted to reduce some part of food waste. So the PEELS comes from industrial processes, and it's could be edible, but not always eaten. And so when we use PEELS, we take them out of the landfills and out of the composter, which is the bottom part of that pyramid, and kind of reintroduce them into the cycle, which is why we called it circular economy focuses.
Yeah, totally. And as we were looking into, well, what's already happening? What's some market research around valorized peels? This dress came up and we just wanted to show it because it's really interesting. So this is from the wine making industry, and it's sort of a wine leather made, or a bio leather made out of wine mash. And it got us excited about, okay, there's a lot of possibility here.
And another part of our process is we actually presented this PowerPoint to our little lab at RIT, and some members of our lab came back with feedback that they had seen similar biopolymers too. And this was an example. So this one is a single sip water biopolymer. It's wrapped in seaweed. And so it used to be used for marathons, but it was never commercially available because it's too fragile and it's not super shelf stable. So that was another one we found that we thought was really interesting. Another thing we wanted to address with our biopolymer is that we did not want it to lead towards greenwashing at all. So a problem that we found within the industry currently is that many biopolymers contain elements like PLA, or they are made and manufactured in a way that they can be composted at an industrial level, but they market towards consumer level composting. And so we wanted to avoid any sort of greenwashing or misleading packaging that would actually lead to worse problems with our biopolymer. So we took that into consideration a lot when making our product.
Okay, so just as a reference point, we're here now in the process. So we've sort of translated and framed our decision. We're gonna pursue a biopolymer around single serving food items, and we've decided to use PEELS, and now we're expanding back out into the research phase. And at this point, we're ready to kind of synthesize that but to send it through the life cycle assessment point.
So part of life cycle assessment is looking to the cradle to grave impacts that your product will have. And to even start that, we had to first look at the impacts that our PEELS would have. So to determine the kind of things we wanted to look at for PEELS, we looked at several factors. A lot of them are listed on the screen. And from there, we were able to narrow it down to 3 peel choices, which were the wine pumice that comes from the winemaking industry, potato peels from the French fry industry, and apple peels from a giant apple industry we have. And what's unique about all of these things is we really wanted to focus on different produces that were regional to New York. We wanted to make sure that they were produced around our areas so that we didn't increase the environmental impact of needing them to be transported to New York, or something like avocados that's only produced in southern United States and in the south of us. We didn't want any environmental impacts coming from that. So we looked at all of these factors to make that determination. And the other really important factor we looked at was the industrial processes resulting in these peels. So the wine industry is a huge industry that produces tons of peel waste through grape pumice. The apple industry, apples go into so many things: applesauce, fruit snacks, and potatoes, of course, are used for a multitude of things as well. So we really took into account all of these factors as a part of that design process, which led us to this next step.
So at some point, you have to sketch and prototype. So we've talked in the student meetings a little bit about sketching and prototyping, but I thought I would talk about it a little bit more because they're so important. So sketching is the visual exploration and communication of ideas, and prototyping is the mock-up and tangible realization of those ideas. And both are really vital to the design process. And part of the reason why that is, and this is true, obviously, in other industries too. We've talked about that, Claire, like in the research and in science, that's an iterative process also. And it's true with design. And one of the most important things, and something we said a bunch, is that we just have to start. You have to put like pen to paper, or you've got to get out your clay, you've got to get your scissors on paper, and you've got to start you have to start making forms, because the way that you can't really have a productive conversation about ideas, that at some point you have to be like this, and then the flap goes like this, what do you think, kind of thing. So we went through that exercise. Here's some of the sketches of the forms that we were exploring. And we also explored forms with clay and paper, and some people call that sort of 3D sketching, and that can be another really useful way to explore forms. We also thought about biodesign, so how nature, which is already so perfect, how can it help us and inspire us? So one of the things we looked at were peels themselves. And so, for example, this orange peel has the little oil sacs on the outside of the first layer in its peel, the oil sacs, which are helping with water resistance. And then you go into the different layers and where there's, spacing and to help with, what's the word I'm looking for? Like
Cushioning.
There you go, cushioning. So we were exploring, like, what can we learn from literal peels already? And now we're here in the Double Diamond. So we've kind of landed on a form that we feel excited about, and we're ready to bring in some best management practices to help us narrow that even more.
In the environmental sustainability world, best management practices are things we talk about all the time. So we always want to incorporate that into our work. And I thought it would be just as important to incorporate it into this project. And one day we were working, we were just finished sketching, we were thinking of what to do next. And ReFed actually released this article about design elements to reduce food waste. And that article was based off of something that the Sustainable Packaging Coalition actually came out with. It's a whole set of guidelines. They have a very thorough work set on it. And we decided that for our product, we wanted to design it in a way that incorporates a lot of these elements. And so we have designed it in a way that it is resealable packaging, which is important because if it's not resealable, it can go bad, obviously. Product evacuation means you have full access to any contents in the packaging. So a big problem with that right now is like peanut butter jars. You can never get all the peanut butter out of the little crevices, which leads to food waste. Visibility, so that you can see through the packaging, is something we would like to play with in the future. Variety and portion and packaging sizes is important because there are different single serving size. So if you need a bigger serving size than others, we thought that would be doable. Compostable is something we will, of course, test one day. And active and intelligent packaging talks about QR codes and relating it to expiration dates and different things like that.
Yeah, and so that brought us to our concept sketch. So this was built in, I use Fusion 360 as my CAD software. So I built this in Fusion 360, and with a concept sketch, it's nice to have sort of the orthographic end perspective on it. So you see what it looks like from the side, what it looks like from the top. In the center, you see the perspective. So you sort of see the 3D image of that. And then there are these little call outs. So you see there's a natural fiber embedded thread that you can pull over for easy opening. There's a potential labeling system with a raised up sort of tactile element for what's inside. And that links back to some of the research that we did. My personal favorite, that it opens up to become a plate, which I feel very excited about. And then a call out here for that the biopolymer is layered, mimicking orange peels. So while this isn't totally been realized yet, this is the concept. This is what we're working towards. And then this is also a rendering of that. So a rendering is sort of you apply materials to the shape that has been built in whatever CAD software you're using. And then to the right, the open piece, that you can take a picture of that essentially and export a picture. And then I sketched in Procreate on top of that some little like goldfish to sort of show scale.
After that, we were lucky enough to get the materials to actually start playing with them and creating a biopolymer. So we already knew what peels we wanted to use, and we looked at a lot of different recipes they had for biopolymers online, but we didn't always like them because we realized that gelatin creates a barrier to different communities. It's not kosher, it's not vegan. And we wanted everyone to be able to use our packaging. So we decided to come up with slightly variations in recipes. And we ended up creating our own procedures and protocols for making our biopolymers. And this is a little bit of what that process looked like. So we had our at-home kitchen lab with all of our supplies set up, and we actually got to experiment with the different materials and create our biopolymers. So if you can see up in the top right corner, the purple colored mixture is actually the grape pumice mixture mixed with xanthan gum, which is a thickening agent, and then we baked it. And the slightly tan colored one right next to it is an apple peel based biopolymer around the same process. And then it's a little hard to see, but there's actually a potato starch based biopolymer right there as well. And that one had some glycerol mixed with it. So we really got to experiment with these and then test the flexibility and the rigidness of them. But one problem we ran into was this. So we'll play. Well, might take a second to load. But since biopolymers are made out of food, we found that they do mold. So that is an issue that, of course, we would have to explore in the future and iterate further on. And then at the end of the summer, we got to present our poster project that we had been working on as a part of the RIT's undergraduate research symposium, where we got to meet a lot of different professors, faculty at RIT, but also students that we made some great connections with. If you want to talk about that, Ariella.
Yeah, so the people who are actually touching the biopolymers, that luckily there were enough that didn't mold, they are packaging science students here at RIT, and they had a project on compostability of, they did an analysis of the compost that came out of packaging that claimed to be compostable. So they analyzed the compost that the company sent them. So they sent them the bioplastic and then also the compost, and they analyzed that. And they were really excited about this project. And so I feel like future convergence could include them and their expertise for sure. And so here we are. We have kind of started to make our way towards what could be a possible solution. Obviously, we still need to I guess essentially one of the things we talked about is we could 3D print the mold that was built in CAD. We could 3D print that and pour some of the biopolymers that were successful into that mold and essentially make actual prototypes that could be tested in real world situations. So while there still would be some looping back, it's not a linear process. That's sort of where we are right this second. And then, yeah, I guess I sort of talked about this a little bit. And then we wanted to take a minute to reflect on the our convergence process. And because I think, Claire, I don't want to speak for you, but from my perspective, it was very successful and a lot of fun. And one of the things we wanted to say was that we thought that our student status was a real asset to us because we came really open-minded and open-hearted to this project and felt like we both had a lot of willingness to learn, I think.
Yeah, and I really, really enjoyed this process because in my discipline, usually you're given one problem or one thing to focus on and research it and address it, but you never actually come up with the solution. You never get to prototype something, you don't sketch, you don't work with your hands. So it was such an eye-opening and engaging and fun experience to actually have an idea and then try to create my actual idea, which is something I never would have been able to do without the convergence process.
Yeah. And I think, you know, the work that we did at the beginning to create those graphics was really helpful because even at moments where we were like, oh, what's happening? We could kind of look back and be like, we're here. This is where we are. It's okay. We still exist in this framework. And I know that helped me. And I think that we had a lot of trust with each other and did turn taking. And, you know, Claire contributed a ton to the design of the layout of the poster, the form itself. We had a lot of, we had a lot of overlap in a way that felt really good. And obviously, like, I helped with the making of the biopolymer. And yeah, so I think that having that overlap was an exciting part of it too.
Yeah, and it was such a unique space in that there was no way to really fail at what we were doing.
Mm-hmm.
So it kind of alleviated that pressure of we have to have this result by this deadline. It was really an open space where we could explore our curiosity and explore different ideas that we wanted to test and iterate on. So it was such a great process to be a part of.
And then I think, do we want to show Figma real quick right before the Q&A?
Yeah. So
okay.
The last part of our convergence process was that we used this website that Ariella had known about called Figma. Do you want to share your screen for that?
I can, yeah. Let's see.
Okay. Let's see. So it's called Figma, and I had never used it before, but how Ariella explained it to me is it was created to design apps to begin with, but you can really use it to do anything. And it works so well for convergence when you have a million different ideas and perspectives that you want everyone to be cognizant of. So we were able to put a lot of our information on this awesome site.
Yeah, so we have here the abstract requirements. Here are some of the early recipes, graphics that we wanted to make sure to include. Here's some of the bio design that we were exploring. Let's see, I wanted to show, sorry, my computer keeps wanting to show me notifications. Here were some packaging, some different interesting packaging that we were looking at. The poster itself, we put together a little bit of a grid. Here's, you know, different color palettes that we were thinking about. And when I designed a logo because I wanted to. And then here you can see different versions of the poster. And then we were able to quickly do a high contrast, black and white poster for increased visibility for people with low vision. And then the website that we put together was also through here. It was I was able to mock it up in there. So yeah, in the interest of really showing our whole process, we wanted to make sure to include that too. And that's free. Figma is free for students. So I'm going to stop sharing and see if anyone has any questions.